Today we will proceed with the next topic, which is about defining classes. For this chapter, we will be starting with the basics of classes and of course how to define class in terms of declaring them, defining them, and of course using them. To start with, let's take a look at the following topics that we will be having for this chapter. First, we will be talking about structures, which is of course will introduce us to the concepts of how classes work and how classes are created. After which, we will be talking about classes. Then finally, we will talk about abstract data types. As we go along, we will learn about those things. But first, let's define what a class is. A class is a data type whose variables are objects. Some predefined classes that you have used are, for example, int, char, or maybe ifstream. The way we see it, we simply consider them as data types. But actually, in C++, they are considered as predefined classes because, of course, they're actually classes with their own methods. But of course, aside from predefined classes, you can also define your own classes, which is what we are going to learn today. So, how do you create your own classes? First, let's talk about class definitions. A class definition includes a description of the kinds of values the variable can hold, a description of the member functions, and of course, to understand what a class is, let's first introduce the concept of structures. First, we will define a structure as a first step toward defining classes. So what is a structure? In C++, we can view a structure as an object, although we don't consider them as a real object. But of course, in terms of concept, they share the same with that of an object in C++. However, it contains no member functions. The structure used here have no member functions. It can contain multiple values of possibly different types. The multiple values are logically related as a single item. Here's an example. Let's say we have a bank of certificate of deposit, and it may contain the following value, or shall we say information. It can contain a balance, an interest rate, and a term. It's just like taking a look at an object, for example, a student record. If we are given a student record and consider it as an object, it can also contain the following values. For example, it can contain your ID number, it can contain your name, it can contain your course, and some other information that are related to an instance of a student. So let's define the definition of the structure that we have mentioned. In this case, if we are going to implement the certificate of deposit as a structure, it can have the following definition. For example, we have here the keyword struct, which of course tells C++ that we would like to create a structure. And in this case, this would be the name of our structure. As you can see here, how we name structures are also similar with how we name variables. Of course, whatever rules that we follow in naming a variable, the same applies with how we name structures. And of course, talking about the definition of our structure, we have the following declaration of variables. We can consider the following variables as the properties or attributes of our structure. In objects, we also call them as attributes and properties. Of course, each attribute is actually an independently declared variable with their respective data types, variable name, and of course, later on, they can be assigned with values that they are going to contain. For now, this is the syntax of how we define a structure in C++. The struct keyword, the structure name, and of course, in its body, which is enclosed with these braces and terminated with a semicolon, it contains the variables which will serve as its properties. So, we've already seen how to define a structure, but how do we use them? Structure definition is generally placed outside any function definition. This makes a structure type available to all code that follows the structure definition. To declare two variables of type CD account, we can do the following. As you can see here, the structure that we declared and defined a while ago will be treated as if it is a data type. In this case, we declared two variables of data type CD account which we defined a while ago. The following variables contain distinct member variables which we declared when we defined CD account structure. How about the structure value? The structure value consists of the values of the member variables. The value of an object of type CD account consists of the following, which means the values that a structure will contain depends on the actual values that were assigned to its member variables, such as in this case, the value for the member variable balance, interest rate, and term. Now, how do we specify member variables? Member variables are specific to the structure variable in which they are declared, which means whenever we would like to access a certain member variable of a structure, we will have to indicate them explicitly. So here is the syntax to specify a member variable. First, we need to specify the variable name for the structure that we would like to access, and of course, we use the dot operator followed by the member variable that we would like to access, whether we would like to get its value or we would like to assign a value. For example, we have the following declaration. We declared two variables of type CD account, which is a structure. Then, we use the dot operator to specify a member variable. For example, we refer to this structure variable, my account. Then we use the dot operator followed by the member variable that we would like to access. So how do we use the member variables of a structure? Member variables can be used just as any other variable of the same type. Here's an example. Let's say we would like to assign a value to the balance member variable of the structure my account. Then we simply use the following syntax, use the assignment operator, and of course, we simply assign the value that we would like to assign to this member variable. Notice that the following structure variables are different variables, which means although they share the same member variable names, but each of these is completely different from the other which exists in the other structure. We can also do the following. To see the details of how structure works, let's take a look at the following example. So here's an example which demonstrates the CD account structure type. As we have seen a while ago, of course, we need to first define our structure. As you can see here, we declared the following member variables. In this case, we initialized each member variable and give it an initial value of 0. And in this case, we also created a function which will be used to give the value that we will assign to our member variables. And here is our main function. What this program does is to simply calculate the interest for a given amount for balance. But anyway, the main purpose of this program is to demonstrate how structures work. So here's an example. In this function, what we do is to simply assign the value to our member variables through user input. In this case, here's an example where we access our member variable balance, interest rate, and term. As you can see here, it follows the syntax that we showed a while ago. The name of the structure, the dot operator, and of course, the member variable name. Anyway, let's try to run this example. Okay, so for example, I'm going to enter 15,000 with an interest rate of 3%, and let's say a maturity of 12 months. Okay, so that will be the output of our program. Anyway, that is just a very simple program which demonstrates how structures work. Let's proceed. A while ago, we've already mentioned about member variable names, which are shared by multiple instances of the structure that we declared. Member variable names duplicated between structure types are actually not a problem. Here's an example. As we can see here, both structures share the same variable name, which is quantity. Although they share the same member variable names, they are completely different from each other. It's because they are variables stored in different locations. And of course, we can also use structures as arguments. As we have mentioned a while ago, we can treat structures as regular variables. Therefore, whatever we can do with a regular variable, we can also do to a structure. And one of them is to use them as arguments to our functions. Of course, talking about arguments, the formal parameter can be called by value, or they can be called by reference. To recall this, we can take a look at our previous lessons which talk about functions. So, here's an example where we use a structure as an argument to a function call. As you can see here, we have here a function declaration, and by taking a look at the parameters, we have actually here a structure variable, which is in this case, it will be used as a call by reference, as indicated by this ampersand. It uses the structure type CD account that we saw earlier, which of course will be used as an argument whenever the function is called. We can also have structures as return types. Structures can be the type of a value returned by a function. Here's an example. As you can see here, we have the following function definition. But if we will take a look at its return type, it is actually a structure, which is in this case CD account. Okay, here's another function, which in this case, this is just actually a helper function, which will give a variable of type CD account a value in this way. Okay. But anyway, that will only be used for formatting. Now let's talk about assignment and structures. The assignment operator can be used to assign values to structure types. Again, using the same structure, we can have the following. As you can see here, we declared two variables of type structure, which is in this case CD account. And as you can see here, we assigned the following values to the member variables of my account. Then finally, we assigned this structure to another structure. In this case, we directly assigned my account to another structure variable, which is your account. So we can do that with structures. We can assign all member variables in your account the corresponding values in my account, as we have seen, which is the result of this operation. How about hierarchical structures? Structures can contain member variables that are also structures. Here's an example. As we can see here, we first defined a structure named date with the following member variables, after which we defined another structure named personinfo, and the following are its member variables. And let's take a look at this one. As we can see here, one of its member variable is actually of type structure. This example demonstrates how we can implement hierarchical structures, in this case, a structure within another structure. So here's an example of how we can use the structure that we declared a while ago. In this case, person info. Let's say we would like to display the birth year of person. First, we access the birthday member of person. We can do this in such a way. However, we want the year, so we now specify the year member of the birthday member. So that's how we do it. So as we can see here, it's still the same concept. Specify the structure name, then using the dot operator, we can specify the member variable that we would like to access. Only that in this case, the member variable is a structure. So to further access its member variable, we use another dot operator where we can finally specify the member variable that we would like to access. How about initializing classes? A structure can be initialized when declared. For example, we have the following structure definition. This can be initialized in this manner. It's so simple. In this section, we've already learned about how to use structures. First, we declare them or define them, then finally, use its member variables using the dot operator. So, can you write a definition for a structure type for records consisting of a person's wage rate and some other requirements such as the following? You can try this for yourself.